Hello guys, in this video, let's see about the next sorting algorithm in this course, that is insertion sort algorithm. So sorting algorithm is insertion sort. So let me clearly explain how the algorithm works. Okay, I think it's enough to know how the algorithm works. So with that, knowledge, you can do a lot on this. So insertion sort. So let me take an array as an example. All right. Right. Okay. Oh my God. Yeah. Yes. So I have certain elements. So let's say I have 9, 5, 1, 4, and 2. Okay. So these are the elements in my array. All right. And after that, what you have to do, the first step in insertion sort is you have to assume that the first element is sorted. Right? The first element is alone sorted. And guys, you may have a doubt now, what do I mean by saying an element is sorted? If I say the array is sorted, okay, well and good. The array is sorted in some manner, either it is ascending order or descending order, whatever. But what do I mean by saying an element is sorted? Okay, the meaning here is if I say an element is sorted, let's get to that example. Say 5, 7, 7, okay, let me go for smaller numbers, 4, 2, 7, 9, okay. Here I could claim that 5 is sorted. How? Because the elements which are left to 5 are smaller than 5, right? The elements which are left to 5 are smaller than 5, and elements which are right next to the 5 are greater than 5, which means that 5 is in correct position. Okay, 5 is sorted. And in between these elements, we don't know whether these elements are sorted, but 5 is definitely sorted because the elements which are lesser than 5 are just left to 5, and the elements which are greater than 5 are right next to 5, right? So that is what I mean by saying an element sorted. Since this is in first position, okay, so let me assume that that element is sorted, right? So first you have to have a temporary variable called key. Okay, so that will do for us. You have to have a temporary variable. So let me write the array again. Okay, so the first step here is very simple. uh, we have to check whether 9 is 5 is greater than 9. Okay, you assume that you are sorting in ascending order, so you have to first check this next element is greater than the previous element. The idea is very simple. Whether the next element is greater than the previous element, that's it, or greater than the current element, I could say, because I'm calling this as next element, so I could call this as current element, right? So is this true? So I have to check just a minute. So I have to check whether 5 is greater than 9. If that is true, and I have to perform a swapping. All right, I have to perform a swapping. All right. So here, of course, here 5 is greater than 9. So what I have to do is I just use this key variable which will store a value. Okay, so the 5 will go here. Okay, 9 will occupy the next position, and 5 will now occupy the first position. Okay, that's how swapping occurs, right? You know that you should have a temporary variable always while performing swapping, and 5 will go to that temporary variable. And 9 will shift to the next position, and the 5 will again come back to the first position. So after the sorted, first two elements will look like this. All right, so yeah, that's how it works. So that's the second iteration. After that, I have to check the next element. Next element is 1. Okay, I know that 9 is already sorted, so there is no need to check 9. So let me check 1. So I have to perform comparison between these two. Of course, 9 is very greater than 1, so I have to perform swapping. Okay, how do I perform swapping? Again, I have to store this 1 in some key variable, right? And I have to shift 9 to this position, and again 1 to the second position. Okay, that's how it works. So what you will get here is 5, 1, 9, 4, 2, right? and after that I should not stop the process. I should stick with 1, and I will again check the previous elements position. But here 5 is again greater than 1, so you should again perform the swapping by assigning 1 to key, by assigning 1 to the key variable, and by shifting 5 and get back 1 to the first position. Okay, so what you will get here is 1 5 9 4 2. Okay, so and here you can see that there is no element to check. Okay, this is the first element, that's it. Let's go for the next element. Next element is 4, right? And here 9 is greater than 4, so perform swapping there. Okay, so 1 5, these two elements are swapped, 4 9 and 2, right? And again I have to perform swapping. If I do that, I'll say 5 is greater than 4, so perform swapping there. So 1 4 5 9 and 2, swap 5 and 4. All right, so 1 4 5 9 2. Again I will say 1 is lesser than 4. Okay, so there is no need to perform any swapping, these are sorted, right? And that's it. Let me go for the next element. Next element is 2, because I know 9 is sorted, so next element is 2. So I know that 9 is greater than 2, so I have to perform swapping, right? So I have to perform swapping. So 1 4 5 2 9, right? And again here 5 is greater than 2, so I have to perform swapping again using my key variable. You know how to perform swapping, right? Using key variable, I assume that you know that. So 1 4 2 5 9, and again I have to compare 4 and 2. So 4 is again greater than 2, so again I have to perform swapping. Here 1 is lesser than 2, so here it is sorted. Okay, I think that's all. Okay, so 9 is our last element, which we have assumed that is already sorted. Okay, I told you the first step is assuming the first element is sorted, so there is no need to check that element. I think this is our sorted result, 1 2 4 5 9. So the main idea here is you have to fix one element. Say this is my set of array. Okay, you have to fix one element. So if you are fixing that element, then you have to make comparisons. So 7 is greater than 4, swap it, we'll get 4 7, right? 5 6 4 7 1. Again you have to stick with that element only until this element is completely sorted, right? Again 6 is greater than 4 only, so you have to perform swapping again. 5 4 6 7 1. Okay, again you have to perform swapping here. So 4 5 6 7 1. Now the element is sorted. So to sort this one particular element, you have taken 4 iterations. To sort this one particular element called 4, you have taken 4 iterations. First iteration, second iteration, third iteration, fourth iteration, right? So until that particular element is sorted, okay, you have to continue the process. Then only you have to move on to the next element, that is 1 in this case. So you can again check comparisons. 7 is greater than 1, so you have to perform swapping. Then 6 is greater than 1, perform swapping there. 5 is greater than 1, perform swapping. So that's the main key point. So two things to be noted here is, one is comparisons, okay, and another one is swapping using key. Okay, swapping using key variable. It's a very simple algorithm, guys. I hope you have understood this. And the since we are making comparisons, right? So we are making inner comparisons. The worst case time complexity for this algorithm will be, O(n) square, right? We will be definitely using two loops. That's why this is O(n) square, nested loops. Okay, so O(n) square, right? So that's the time complexity of this particular algorithm. I hope you have understood this. So thanks a lot.